Singed cracks a vial. A green cloud spills out, curling over cobblestones, sliding between pipes, pouring down staircases into the Undercity. In the shot, it feels obvious. Poison goes down. Zaun becomes a bowl, and everyone below is trapped inside it. But freeze that frame. Is that actually what poison gas would do? Would it sink into Zaun's trenches and sewers, or rise through vents and bridges toward the skyline? The unsettling answer is, both are possible. Not because poison is magical, but because air is messy. The first trap is the word poison. Poison tells you what a substance does to a body. It does not tell you how it moves through a city. A gas can be deadly and heavier than air. Another poison could behave differently, and a visible cloud might not even be a pure gas. It might be a fog of tiny droplets or particles. So the real question is not, is it toxic? The real question is, what kind of thing is moving through the air? Imagine 3 invisible labels hanging off singed vial. The first says density. Is this material heavier or lighter than ordinary air? The second says release. Does it come out cold and slow or hot and pressurized? The third says environment. Is it released in an open street, a sewer, a tunnel, or a dense city canyon stacked with bridges and towers? Change any one of those labels and the path of the cloud can change. For a real-world warning, look at hydrogen sulfide. It is a toxic gas associated with sewers, manure pits, oil and gas operations, and other industrial settings. OSHA describes it as heavier than air, able to travel along the ground, and capable of collecting in low-lying or enclosed spaces such as manholes, sewers, and underground vaults. That is almost too perfect for Zaun. Lower levels, pipes, drains, tunnels, and confined rooms. This is where the Undercity becomes more than a backdrop. If singed chemical behaved like a dense gas, it would not need to chase anyone. Gravity and poor ventilation could do part of the work. The cloud could spill over a ledge, slide down stacks, thicken in a basement, or sit inside a sewer chamber where fresh air barely reaches. To someone on a bridge above it, the danger might look like a low fog. To someone below, it could be the entire atmosphere. And there is another grim detail from hydrogen sulfide. Smell is not a reliable warning. At low concentrations, it is known for a rotten egg odor, but OSHA warns that after exposure, especially at higher concentrations, your ability to smell it can fade. So the cinematic scene where people notice the stink and run is not always how toxic gas works. Sometimes the warning system is the first thing the gas steals from you. But this does not mean all poison gas sinks. That is the second trap. The fact that something can harm you says almost nothing by itself about whether it pools at your ankles, mixes through a room, or gets carried above your head. Now put the chemistry inside a city. Zaun is not an empty laboratory chamber. It is a vertical maze. Streets become trenches. Buildings become canyon walls. Pipes, vents, bridges, fans, furnace stacks, and tunnels all carve pathways through the air. In a simple cartoon, heavy gas goes down and light gas goes up. In a real urban environment, the city grabs the plume and folds it. Researchers studying high-density cities have found that closely packed tall buildings can reduce ventilation and limit how well pollutants disperse. That means pollution near the street does not always simply mix away into the atmosphere. It can linger where people are breathing, especially when the built environment blocks or weakens airflow. If Piltover is open sky and Zaun is compressed layers of masonry and metal, Zaun's shape itself becomes part of the hazard. The key idea is the street canyon, a road or passage flanked by tall structures. Wind moving over the top does not just sweep the canyon clean like a broom. It can create complicated air movement inside the street, trapping and recirculating pollutants. One side of a passage may be flushed, the other may become a pocket of dirty air. A plume can bend around corners, climb a wall, sink into a stairwell, or smear out into a hazy layer. Reviews of urban street canyon research point to building height differences and incoming airflow as major factors in pollutant dispersion. In other words, the same poison released on 2 different blocks could behave differently. A narrow alley under a high bridge might trap it. A street aligned with strong wind might channel it like a toxic river. A change in airflow above rooftop level might pull some of it upward while leaving a denser layer below. That makes Zaun terrifying in a specific way. It is not just low, it is irregular. The rooftops are uneven, the streets are crooked. Air enters through gaps, shafts, vents, and industrial openings. A bridge can shield one passage from wind, while accelerating air through another. A ventilation path might clear one room and send the plume into the next corridor. Now add the green cloud itself. In fiction, poison gas is usually visible because visibility is dramatic. But many pure gases are invisible. A visible cloud often means something else is happening. Droplets, particles, smoke, vapor condensing, or a mixture. NASA describes aerosols as tiny airborne particles, including dust, soot, mold, and bacteria that are important in atmospheric processes and cloud behavior. A sinister green plume could be closer to a toxic mist or aerosol cloud than a single pure gas. That twist matters because aerosols do not behave exactly like a simple gas. Depending on particle or droplet size and airflow, parts of an aerosol cloud may stay suspended longer, while other parts may settle or deposit. Some may ride turbulent air like smoke. A cloud can also change as it moves through different conditions. What you see as one green shape could be a mixture of particles and vapors moving in different ways. This is why scientists study aerosols in clouds with measurements and computer models rather than one-line rules. Their composition, distribution, and development depend on atmospheric processes. Scale that down to Zaun, and Singed's release becomes a dispersion problem. Chemistry plus architecture plus time. The plume at second 5 is not the plume at minute 5. So let's run the Zaun scenarios. If Singed releases a cool, dense toxic gas at street level in a poorly ventilated lower district, the nightmare version is plausible. The gas could crawl along the ground, pour into depressions, collect in sewers, and linger in enclosed rooms. People in low places would be in the greatest danger. The Undercity's trenches would act less like streets and more like channels. If the same substance is released from a pressurized device, the first few seconds could be different. Momentum could blast the cloud outward or upward before gravity and mixing take over. If it comes out hot, it might initially rise because warm air is buoyant, but as it cools and mixes, a dense component could spread differently. The first motion is not always the final fate. If strong wind cuts through a canyon street, the plume might stretch into a long ribbon. That can reduce concentration in one spot, but carry danger farther away. Someone close to the release might be spared by a gust, while someone around a corner meets the plume after it has been steered by the buildings. In a city, away may just mean somewhere else. If the green poison is aerosolized, the question becomes even less binary. Some of the cloud may remain suspended and travel with turbulent air. Some may settle or deposit depending on particle or droplet size and airflow. A visible plume rising into the skyline would not prove the streets below are safe. A low fog would not prove none of it is being carried upward. The most realistic answer is not a single arrow pointing down or up. It is a branching map. Dense gas in low enclosed spaces, down and pooling. Warm release in moving air, rising, spreading, then mixing. Aerosol mist in a street canyon, swirling, hanging, settling, and drifting wherever the city's airflow allows. Singed would not just be using a poison, he would be using Zaun's ventilation, or lack of it, as part of the weapon. So would singed poison gas crawl through Zaun or rise into the sky? If it is heavier than air and released into low confined spaces, it could crawl, pool, and turn Zaun's lowest levels into traps. But if it is warm, turbulent, aerosolized, diluted, or caught in vertical airflow, parts of it could lift and spread unpredictably. The answer is not simply down or up. The chemistry decides what the cloud tends to do.